Topic: Is the rise of EV sales proportionate to the increases in gasoline and diesel prices in Canada? A 2017 to 2021 analysis. Introduction. Henry Ford revolutionized the automotive industry with his affordable Model T, released in 1908. But did you know that the first electric car in North America was introduced in 1890 by William Morrison, predating Henry Ford's popular Model T by almost 2 decades? For the better part of our automotive history, gas and diesel-powered vehicles have vastly outsold their electrical counterparts. In the late 1990s, Toyota introduced the world to the Prius. The Prius is the first mass-produced hybrid electric vehicle and marks the turning point for the automotive industry. Since its introduction, EVs have steadily grown in popularity. According to Forbes, electric vehicles are gaining popularity and market share. In Q2 2022, EV sales accounted for 5.6% of the total auto market, up from 2.7% in Q2 of 2021. While searching for data sets to use in this open data project, I found several tables regarding vehicle registrations on the Statistics Canada website. One data set in particular focused on new registrations and contained categories for electric vehicles. On a quick glance, it appeared that the number of new EVs was steadily increasing. This raised the question of, is this affecting fuel sales? So more searching on the website provided several usable data sets to research my inquiry. The first data set examined is titled Vehicle Registrations by Type of Vehicle and Fuel Type. The data set spans the years of 2017 through 2021. The data set is broken down into several categories. One axis of the table breaks down the style of vehicle into several classes, including total vehicles weighing less than 4,535 kilograms, total vehicles weighing between 4,536 to 11,793 kilograms, total vehicles weighing 11,794 kilograms or more, buses, motorcycles, and mopeds. The other axis displays the number of registered vehicles by fuel type per year. Categories include gasoline, diesel, battery electric, hybrid electric, plug-in hybrid electric, and other fuel types. I opted to focus on total road motor vehicle registrations, which is the sum of all vehicles because all vehicles contribute to the sale of fuels or require electricity in the case of EVs. I combined gasoline and diesel into a fossil fuel category and combined battery electric, hybrid electric, and plug-in hybrid electric into the electric fuel category. These new categories will help us separate vehicles that are purely driven by fossil fuels versus those who are electric or electric supplemented. The combined table displays the number of vehicle registrations of each style per year. The second dataset examined is titled Sales of Fuel Used by Road Motor Vehicles. This dataset spans a greater number of years than a previous dataset, but does encompass the years covered by a first dataset. One axis of the table breaks down the net and gross sales of fuels into 3 categories: gasoline, diesel oil, and liquefied petroleum gas, better known as propane. The other axis shows the liter total of each type of fuel sold by year. This axis has the potential to be broken down by province, but I've opted to examine Canada as a whole. The combined table displays the sale of fuel by type per year. The third dataset examined is titled Monthly Average Retail Prices for Gasoline and Fuel by Geography. This dataset also covers the time span of our first dataset. One axis on the table shows us the geographical locations broken down by province, and since we're examining Canada as a whole, we can just focus on the Canada column. The other axis of the table contained prices for regular unleaded gasoline, premium unleaded gasoline, diesel fuel, and household heating fuel, and is broken into monthly average prices. For this axis, we will focus on regular unleaded fuel and diesel fuel because premium prices are derived from regular prices and household fuel are outside the scope of our research. The combined table displays the average price of fuel type per liter per month in Canada. Results. The average retail price of fuel type per year. For this dataset, I chose to present it as a bar graph, as it seems to be the most straightforward way of conveying the information. I opted to contain the information into 2 groups, regular unleaded gasoline and diesel fuel. As mentioned, the price of premium fuel is derivative and the household fuel is irrelevant in the scope of this project. The purpose of this graph is to establish a baseline for how much fossil fuels Canada is using on a yearly basis. The results are interesting as they do not show a clear pattern of change over the sampled years. However, I find it interesting that the price of diesel fuel spiked dramatically in 2020 during the COVID pandemic. This is likely attributed to the ongoing need of goods and new limitations placed on the transportation industry. Total sale of fuel in liters per type per year. For this dataset, I chose to present it as a bar graph as well. This graph outlines the total amount of fuel sold by type annually. The values represented in the left column have a scalar value of 1,000, making the presented number 1,000 times less than the actual use. I opted to include all the available fuel types, even though propane makes up very little impact in the marketplace. The purpose of the graph is to help establish if the amount of fuel being consumed annually has an impact on the price. Similar to the above graph, we do see dips in gasoline sales in 2020 and 2021 that are likely ties to the COVID pandemic of those years. We also see a dip in diesel sales, but not nearly to the extent of gasoline. This is likely attributed to the continued need for transported goods during the pandemic. It's interesting to see that the numbers seem to be slowly returning to the pre-pandemic levels, but more time and data will be required to confirm that notion. Difference in average total vehicle registrations against previous year. For this data set, I took a different approach than the previous graphs. Due to there being an overwhelming difference in the number of electric vehicles versus conventional vehicles, choosing to display the percentage growth against the previous year seemed to convey the data better. For this graph, I created two categories: fossil fuel burning vehicles and electric or electric supplemented vehicles. This was done because hybrid vehicles by nature contribute less to the consumption of fossil fuels. The purpose of this graph is to show the growth or decline of the two categories of vehicles. To understand the graph, any column with a bar above 0% indicates that more of that style of vehicle has been sold this year compared to the previous. For example, if 100 cars were sold the previous year and the graph showed 10% growth, that would indicate 110 cars were sold that year. Although the data set doesn't cover a great deal of time, it shows some interesting results. Until 2020, it seemed that EVs were in a state of considerable growth, increasing in 2018 by nearly 25% over 2017, then increasing nearly 29% the following year. At the same time, it appears that conventional vehicles were in a state of stagnant growth. They indeed outsold themselves over the previous year, however, the growth rate was in decline. The 2020 pandemic expectantly caused a dip in growth in both styles of vehicles, but as shown, conventional vehicles took a substantial blow. 2021 shows the only negative growth in the dataset, but it is significant. While EVs continue to grow with good margins, conventional vehicles are now being registered less than the previous year. This clearly indicates the decline in registered fossil fuel burning vehicles in Canada. Analysis. After developing these graphs, I find my initial proposition is the rise of EV sales proportionate to the increase in gasoline and diesel prices in Canada to be inconclusive. There doesn't seem to be any clear indicators that the data I've garnished to show a correlation between them. While the prices seem to be relatively stable in the dataset, the consumption becomes skewed during 2020 and 2021 due to the pandemic. My data shows that while EVs are becoming more popular, it doesn't appear to currently affect the price of fossil fuels. Conclusion. Given thought to the information I presented, I realize that EVs may indeed affect the price of fossil fuels, just not in a way measured by these metrics. Fuel suppliers may be inflating the price to compensate by the void created by EVs, what was my initial thought, or it could be an issue in supply policies. The rising cost of fuel can be attributed to many factors not explored by this study. One conclusion can be made clearly, however: electric vehicles are more popular than ever. I was quite surprised by their growth rate, even in the face of the pandemic. It will be interesting to see these graphs with a few more years of information available to compute.